Hi there! Welcome to a new physics lesson filled with adventure and discovery. Today, we're going to take a look at sound and strings as a way of introducing sound to you, sound and physics. We talked about waves, we've talked about the different things that we can measure in waves, and today we're going to be looking at how we can make sound waves using a string instrument such as a guitar. And so let's jump into it. So first of all, the sound and strings, we can make and produce sound waves using a vibrating string. Whenever something vibrates or molecules bang into each other, we can get sound waves. We can get vibrations in the air, which go into our ears, and our ears can register that as sound. And so sound is produced by strings, and I don't know if you can see it, but I have my guitar here, my Jasmine guitar, and as I pluck a string, it vibrates and it produces a sound. So this is the G string, and it's a very low note, and you can hear that sound because it's vibrating. And so we're going to take a look at all the different nuances of these strings. So vibrations, first of all, the higher the pitch, the more vibrations there are, because there's faster vibrations, and then vice versa, the lower the pitch, the lower the frequency of the note, the less vibrations there are, and the slower the vibrations are. And so if you notice here, on my guitar here, on the very top string, this very thick string, it's a very low note. And the reason for that is because the string is vibrating at a slower rate than, say, this really small string, which is at a very high note, because the vibrations are faster and the pitch is higher up. Okay, loudness. The way I can make the string louder is, and you might have played a string instrument before, if I pluck it very softly, it's very soft. However, plucking a string harder makes it very loud. However, notice, an important note here on your screen here, the harder I pluck the string, it's the same pitch as just a really soft noise, but it's just louder. And then a couple of laws of the vibrating string. Law number one, the longer the string, the lower the pitch. And so notice my G string right here, that's top string. I have these tuning knobs at the top of my guitar. And if I were to shorten the string or make the string shorter, as such, other way, okay, I can actually make the pitch higher. Because I am tightening the string, I am shortening the string. Okay, that's how we tune guitars as well. So that's law number one. The longer the string, the lower the pitch. The shorter the string, the higher the pitch. Law number two, the more tension in the string, the higher the pitch, and the less tension in the string, the lower the pitch. And so notice, if I tune my guitar and I make it lower, there's less tension in my guitar, and because of that, the pitch is lower. Okay, there's less tension in the string. But if I bring it back up, there's more tension in the string. The string is shorter, and my pitch is a little bit higher. Okay, and so a couple other laws. How does this relate to sound? Well, wavelength and frequency are inversely related to each other. They're kind of like opposites. The higher my frequency, the shorter my wavelengths are. And the lower my frequency, the longer the wavelengths are. One goes up, one goes down. However, frequency and pitch are directly related, which means if my frequency is high, then my pitch is also going to be high. And if my pitch is low, then the frequency will also be low. Okay. So here's kind of a chart of all those things. So, for example, speed of vibrations. If I increase the speed of my vibrations, what's going to happen to my three variables here, wavelength, frequency, and pitch? So, if the speed of my vibrations increases, okay, I make my vibrations faster, okay, what's going to happen to the wavelength? Well, the wavelength is going to decrease. However, what happens to my frequency? What happens to my pitch as I increase the vibrations? Well, my frequency increases and my pitch is going to increase. So although the wavelength, the actual sound waves decreases, okay, the wavelength gets shorter and shorter, the wavelength decreases, the pitch gets higher and higher and higher. If my wavelength increases, okay, if I have longer wavelengths, my speed of vibration is going to decrease. Okay, so notice I am increasing the wavelength. What's happening to my frequency at this time? Well, my frequency is going to decrease, as well as my pitch. And as you can see, that's exactly what happens to my guitar. If the frequency increases, what happens to the speed of vibrations? Well, the speed of my vibrations, if I make the pitch higher, frequency increases. Okay, my speed of vibrations are going to increase. My wavelength, opposite of frequency, decreases. And my pitch, which is the same as frequency, is going to increase. Lastly, if the pitch increases, what happens to these three variables? Well, speed of vibrations increases. Okay, so if I increase my pitch, the speed of my vibration is going to increase. The wavelength, however, decreases, okay, because the wavelengths get shorter and shorter and shorter. The frequency is going to increase. My frequency, the pitch, is going to go higher. And that's kind of how these variables work on a string instrument. Okay, and so really cool introduction and way of introducing sound to you guys. Thank you so much for joining us, and we'll see you next time.